Hey guys, welcome to another lesson. And today we're looking at chemical bonding, right? So this is just a little lesson to basically describe simple terms the three types of chemical bonding there is, right? So we have three types of chemical bonding, and bonding is where we use atoms to actually get a compound, right? So it's the general method of forming compounds by bonding atoms together, right? So we have one type, which is the ionic bonding. And this type is a very popular type of bonding. So this is only between metals and non-metals. So you have to have a metallic element and a non-metallic element, right? And we know that metals are elements that are from group 1 to 3, and since it's our new revised periodic table, group 1 to 13. So that means they have electrons 1 to 3 on their outer shell, right? So any atom that has 1, 2, or 3 electrons on their outer shell is known as a metal. And non-metals are from group 15 to 17, right? And in that case, they have 5 to 7 electrons on their outer shell, right? So group 8 or 18, as you know, would not involve in bonding, and that's because they are already full. They don't need to lose or gain electrons, right? So they already have a full, stable structure, right? So there's no need to lose or gain electrons, right? Because bonding involves atoms that are unstable, meaning that they need to actually fill up to get 8 electrons on their outer shell, right? And then we have covalent bonding. This is the sharing of electrons between non-metals. So with covalent now, it only applies to atoms of non-metals. So there is no metal involved. So only non-metals. So 2, 3 non-metals bonded together, sharing, right? So the key words is sharing electrons, and it has to be only with non-metals. And then metallic ones, this is a rare one, right? So this is a bonding which is caused by the attractive force of positive metals, right? So metals that have already lost electrons, so they are now positively charged, right? So it's attraction between those metals and the electrons of other metals that have not yet lost electrons. So because of that, they are confined that attractive force between positive charge and the negative electrons. That attractive force keeps them compact in a very short, small space, right? And that is a form of bonding, right? So this one is not popular among examiners, right? They normally focus on joint structures for ionic or covalent, but it's important to know what metallic structures or bondings are, right? So let's look at some examples for ionic and covalent bonding, right? So let's go with a simple one, which is we're going to bond sodium and chlorine. All right, so what we're going to do, we're not going to draw the entire structure, right? So we're just going to use the outer shell. So we have the nucleus of sodium, which is 11 protons, right, and 12 neutrons. And then it has 1 electron. So we're using the dot and cross method, right? So we have 1 electron on your outer shell, right? And then for chlorine is 17, right? And we're going to 18 neutrons. But chlorine now has 7 electrons on its outer shell. Sorry, let's use the X's here, so we don't get confused. That's the purpose of the dot and X method, so you don't get confused, right? So the first thing to note in our bonding process is to define if our metals or non-metals or elements are. So we know sodium, it has 1 on the outer shell, 1 on the outer shell is metal. We have chlorine, which has 7 on the outer shell. 7 on the outer shell is a non-metal. So because we have a metal and a non-metal, then that means an ionic bonding, right? So now with ionic bonding, what happened is that we have a transfer of electrons. So in this case, this electron here from sodium will transfer itself over to chlorine, right? So it transfers itself to chlorine. So now chlorine has 8, right? And now this outer shell that only had 1 for sodium will be lost. So the next available shell will have 8 for sodium, right? So in this case, we used 1 sodium to bond with 1 chlorine. So the chemical formula of sodium bonded with chlorine would be NaCl. All right, and that's the same for 1, and we know that is table salt, right? So let's look at another one. So let's look at magnesium and let's still stick with chlorine here. All right, so we know magnesium is 12 and 12. So in magnesium has 2 on the outer shell, right? And then we know chlorine, 17, 18. Chlorine has 7 on its outer shell. All right, so in this case, we identify if they are metals, non-metals, right? So magnesium has 2 on the outer shell, 2 lies between 1 and 3, so it's a metal. And we know chlorine has 7, which we know it's a non-metal. So metal, non-metal, still ionic bonding. So again, we do transfer of electrons, right? So we take this 1 electron and we go there for chlorine. Now, we notice now that chlorine is balanced, right? Because it now has 8 on the outer shell. But magnesium still has 1 that's remaining. So what you think will happen is that we get a next chlorine that can accompany or take that electron. So now we're going to need another chlorine. Right, and this chlorine here will take this electron to make magnesium now be balanced. So now we lose these 2, so magnesium now, the next outer shell has 8. These 2 chlorine atoms have 8. So the formula of magnesium bonding with chlorine would be that we used 1 magnesium, so that's Mg. So we don't put the 1 there because it's just 1, right? So it's Mg, right? And then we use 2 chlorine, so that is Cl2, right? So magnesium chloride is MgCl2 because we use 1 magnesium to bond with 2 chlorine, right? Let's do a next. All right, so we're going to do 2 more, right? So we're going to do carbon and oxygen, right? Now this one is a unique one, right? Because carbon, which is 6, it only has 4 on the outer shell, right? And we did not make mention of what will happen with atoms of 4. So with carbon normally has bonding with covalent structures, right? So carbon in this case will behave like a non-metal, right? And then we have oxygen, which is 8, right? And oxygen will have 6 on its outer shell. So we have that, all right? So in this case, we're going to have carbon and oxygen being bonded. We know oxygen have 6, so that is a non-metal and a non-metal, so that is covalent. So now we have to share, right? So instead of transfer, because that's ionic, covalent, now we share. And sharing involves the two atoms, right, giving the same amount of electrons in that sharing loop, right? So what we have when they share, right, is that we know that carbon needs 4, right, and oxygen needs 2. That's correct, right? So we use the smaller one to show how much we're going to share. So that means each atom will share 2. So let's go. So we're going to use carbon. Here's 6, 6, right? And we're going to draw. So if we're sharing 2, that means we're going to group the 2's together, right? Because remember, we need the lowest one is 2. So carbon is going to share 2 and oxygen is going to share 2. So oxygen now will share 2. So put 2 there, right? And this is 8, 8. So this is 4, 5, 6. Right? So now if you cover this carbon and we count the amount of electrons we now have, because this 2 electron is shared with oxygen, right? So we have 4 here, 5, 6, 7, 8. So now that oxygen is balanced, right? Because it has 8. Now if we cover the oxygen and we count the carbon, this is 4, 5, 6, right? So now carbon needs 2 more, right? So we can't use any other element because we're only using carbon and oxygen. So that means on this side, we're going to use oxygen again, right? To share another. Remember, only can share 2 because needs 2, right? So if we cover both oxygen, right, we now have 8, 4 on each side for carbon, right? And we cover this one, 4, 5, 6, 7, 8. So oxygen both has 8, carbon has 8. And in this case, we know to find the formula, it is how much carbon we use, right? And in this case, we used 1 carbon, right? And we had 2 oxygen, so that's O2. And this is something popular that you know, which is carbon dioxide, right? So that's how carbon dioxide is created, by sharing electrons between carbon and oxygen, all right? So let's look at carbon and nitrogen, right? So, oxygen and nitrogen. So we know nitrogen, which is 7, right? So it has 5 on the outer shell, right? And we already know oxygen has 6 on the outer shell. So we know oxygen needs 2 and nitrogen needs 3, right? So again, they're both nonmetals because this is 5, it's more than 3, and this is 7, and this is 6, right? So both nonmetals, so we go again with sharing, right? So we go again with using the smallest one, right? So the smallest one that we need, the smaller one is the nitrogen, which is the oxygen, sorry. So we're going to share 2 each. So 7p, 7n. Alright, so we group in 2, and then 8, 8. So this now will give 2 here. So that's 6, 7, 8. 4, 5, 6, right? So if we cover nitrogen, we notice we have 8 electrons for oxygen there, right? But if we cover oxygen, we have 4, 5, 6, 7. 7, right? So this needs 1. Alright, so since we share this 1 here, right? Now that 1 showed that now oxygen has 7, right? It needs 1 more. So that means we have to introduce the nitrogen to give it 1, right? And now this nitrogen has 6. So that means this nitrogen needs 2. So we give a next oxygen, right, to give 2, right? And that now gives us oxygen being 8, right? So in this case, the formula would be how much nitrogen, which is 1, 2, how much oxygen, 3. Right? So that would be the formula of nitrogen having a covalent bond with oxygen. Alright, so thank you guys for watching another video and hope you enjoy. See you guys next time.